Welcome. This is Math 222 or Differential Equations Common 2 2019 Fall. This is the exam they gave to the students, and I'm gonna be doing the problems and showing you how to do each one of them. And this is like a little review session before the exam. Alright, let's get started. So the first problem asks you, it wants you to find these like the general solutions of each of these, and it wants you to match these expressions with them. So let me do the first one. So the first one, this is y double prime minus 6y prime plus 25y equals 0. So this is a homogeneous equation, so we know it's very straightforward. So I can change this down to r squared minus 6r plus 25 equals 0. Okay. Now, I don't really know, like, I'm not going to try to factor this. I'm going to go right to quadratic equation because that's going to be one of the easiest things to do. So I'm going to say, okay, so 6, because they mean minus b, so minus and minus becomes positive, plus or minus, this would be 6 squared, which is 6 times 6 is 36, minus 4 times 1 times 25. Well, we know 4 times 25 is going to be 100. Cool. And this is going to be 2 times the coefficient from this, which is going to be 1, so it's going to be 2. And this will equal your R value. So 36 minus 100, so if you don't know how to do that, I'll show you for the side. So I'm going to reverse it. I'm just going to make it negative. So this is going to be, this is a 6. Um, so 0 minus 6, 0 minus 3. So you can't do that, so you got to borrow this. This becomes 0. This becomes a 10, but you have to borrow this, so this becomes a 9, and this becomes a 10. So this becomes a 4, and this becomes a 6. So I'll have negative 64 there. And if you know you did it right, you'll get something that will simplify in the radical. If you didn't, then you probably screwed up with your subtracting somewhere. So always be careful of that. So this becomes 6 plus or minus negative 64, all divided by 2. Okay, cool. So what I'm going to do is I'm going to simplify this down. So this becomes 8i, so it'd be 6 plus or minus 8i divided by 2. And then this now becomes 3 plus or minus 4i equals r. Okay, so what I want to do is I want to plug in, so this becomes, so I want to do my general equation. So we know from the derivations from Euler's equation, or Euler's equation, this will now become e to the 3t c1 cosine of 4t plus c2 sine of 4t. And this is your general equation. This will equal y, or whatever you want. I'm gonna say y because it's gonna be the easiest thing. Most of the time it could be y, it could be u if you're using a if you're doing a spring problem. So okay. So after I've done that, I want to plug in infinity. So you do a limit, but I can just visualize this. So I want to see, so these are going to oscillate back between their maximum amplitudes. You know, like if this is one, it would just be going back and forth, back and forth. By having an E out here, well, we know the graph for E looks something like this, right? So it's going to be increasing. This is going to be just a constant amplitude. It's going to be going back and forth. So I want to read these. So every solution approaches 0 as t approaches infinity. Not really, because we know this is going to oscillate. Approaches 0, not really this one either, because they're not approaching 0 or infinity, they're oscillating. Not really this one either. Um, this one though, every non-zero solution has an oscillation, which becomes progressively larger. So we know as e to the t, or e to the 3t doesn't really matter, just has it's going to be approaching a little faster. This will get larger as time gets very, very large, and this is going to be oscillating. So we can conclude that, judging by this is not really this is oscillating. This whole function is oscillating, and this is increasing. We can say it's going to oscillate and increase. So we can say this is going to be this. Cool. And I'm going to get rid of this, and we're going to do the next problem. Okay, this one. So first thing I see is I want to clear the 3. So this now becomes y double prime plus 4y equals 0. Just make my life a little easier, because this would be 0 divided by 3, which is of course 0. It's just easier to do this. And then I'm going to change this into r squared plus 4 equals 0. And I'm going to do r squared equals a negative 4. That means r must equal plus or minus 2i. Okay, now I have that. So what I want to do is I want to do the same thing before. Now since I have so the general form would be this, and then this will turn into e to the at c1 cosine of bt plus c2 sine of bt. Okay, cool. So I have no a at all. You can see this is an imaginary part. So this is technically just going to 1, because if it goes to 0, this whole thing would just be blows up and it's nothing. So this is actually a 1, but I only have b, so all I just need is c1 cosine of 2t plus c2 sine of 2t. Okay, so I want to look at this. I look at this. It's not increasing. It's not decreasing. There's no e. There's no e raised to the power of negative or positive. It just I have an oscillating function. So what I conclude is that if I read this, every non-zero solution oscillates with a constant amplitude. So this one fits it perfectly because it's not going to increase, not decreasing. It's just going to oscillate with a constant amplitude. The amplitude being c1, c2. So of course this becomes this. Okay. Next question. This this is a problem that can be factored. So of course I'm just going to change this to r squared minus 3r minus 4 equals 0. So what multiplies to a negative 4 adds to a negative 3? That would be simply r minus 4r plus r minus equals 0. Okay, cool. Now I want to factor. So I want to factor out r here. And I want to factor out 1. Yeah. Yeah, I want to factor out 1 equals 0. So r plus 1 and then times. Okay, cool. So this equals 0, so my r, so I'm going to have my general solution, so r would equal negative 1 or 4, so y would equal c1. Doesn't matter what you put your c1, c2, doesn't matter what power it's raised to, doesn't matter, it's still constant. If you did the equation, you get the same value as whatever, like if you got c1 reversed to c2, it doesn't matter. So I look at this, and I'm going to see what, if I plug it, if when time gets very, very large, I'm going to see 1 will always approach 0, because it's going to, this is just a normal e function. This will approach 0 as time gets very, very large. So I'm going to have a 0 solution. I'm going to have a really big solution. So we can say that infinity. So I look at my answers. Has a non-zero solution that approaches 0 as t goes to infinity or very large. And then and then when we approach infinity as t, it gets very big or infinity. So clearly this is the only one that will fit the bill. Just because not all the solutions approaches 0, not all of them approaches infinity. They're going to have one be 0, one, like this term's going to be 0, this term's going to be infinity. And that's it for that part. So we got one more question 1. So this one. So of course I'm going to do the same thing I did for all these problems. I'm going to convert to r squared plus 10r plus 25 equals 0. Okay. I can see this to be factored, so it'd be r squared. And all you can do the quadratic equation, doesn't matter, same thing. It's gonna get the same answer. Just if you can see it be factored and don't screw up on your factoring, it'll be fine. So this breaks into something like this. Equals 0, so I pulled out r here, so this becomes r plus 5. And then I'm gonna pull out 5 here, so plus 5, r plus 25 equals 0. 5, my bad, not 25. Don't know why I said that. 25 divided by 5 is 5, so my mistake. So this becomes r plus 5 squared equals 0. Okay, so that means r equals negative 5. Okay, so I only have one value, so what could that mean? Well, this is a repeated root. So all I have to do is, it would be y equals c1 e to the negative 5t. But I can't have the same thing. I can't have a c2 e to the negative 5t, because that just doesn't make sense. The equation, it's like, why do I have two of the same thing? So the simple solution is just multiply by t. And that's, if you actually did a proof of this, you'll get just, it'll be always a factor, multiply by a factor of t. So something like this, which now you can see, if I plug in infinity here, I'll get a 0. Okay, now here, I'll have infinity times a 0. Okay, so now I mean, you can visually see this will go to 0, but to prove it to yourself, it would be this. Now I'll take a L'Hopital's rule here. T goes to infinity. So this becomes infinity over infinity over infinity. That's a plus. And I'll take a derivative of that, so it'd be 1 over 5e to the 5t. And of course, this now goes to 0, so both go to 0. That means it only can be number 1. It doesn't go to infinity, and it doesn't go to, I believe, 3. Yeah, it's not this either. It just goes to 0. So that's it. Okay, next question. Now this is question 2. Now this is something called reduction order. Now these are one of the hardest problems on the exam just because of the math of it. There's two ways you can do it. They want you to do it the long way, so there's actually a fast way to do it, like such as the integral, which I will show you at the end of it to check your work. But they don't want, if you just show the integral, you won't get many points for it because they want you to do it the hard way because why not? Okay, so I have y1 equals t squared. Okay, cool. So to figure out y2 is, I'm gonna multiply by something called v. It doesn't matter, it's just a variable, just v right here. Doesn't matter what you can call it. You can call it anything you want. Call it w, call it x, whatever. I'm just calling it v. Most people call it v. It does not matter. So I want to take two derivatives of this. Why? Because I want to plug in here, here, and here. If I did, and to make that verify this is a solution, you can take two derivatives of this and then plug this in, and you'll get this equals 0. But we don't need to do that. It's not proving this is a solution of this. It wants to figure out another solution by reduction order. So this, you don't need to take two derivatives. This is just y2. So unless they ask you to prove this, which is different question. But anyway, take the two derivatives of this, which is dy dt. Now, of course, there's a product rule. This is not constant. This is a variable, which I'm trying to solve. I'm trying to solve for at a certain step. I'll solve for this. So this would be 2t times v, and this would be plus. Now I'm gonna have to take the derivative. This is not constant. This is gonna be v prime t squared. Okay, cool. So now what I want to do is I want to take a second derivative of this, which will become d, the second derivative of this becomes derivative of t is just 1, so it'd be this, and then it'd be plus the derivative of this, which becomes 2tv prime. Now I'm going to take now I got two product rule, and now I'm going to have another two product rule. So I'm going to take the derivative of this, which would be plus 2, uh, like this, so it's going to be 2tv prime, plus, now I'm going to take a derivative of the v, so it'd be v double prime t squared. Now I want to simplify this down, so it becomes t, we'll first write this, and it becomes 2v plus 4tv prime plus v double prime t squared. Okay, so this is, I'm getting somewhere now. Okay, so now I have y double prime, which is the second derivative, and y prime. So what I want to do with that, I want to plug back into the difference equation, and what's going to happen is if you know you did it right, you're going to see the v's will go away. Always the v's will go away. If you did it right, the v's have to go away. And if you didn't, that means you screwed up with your derivative or you screwed up with your math. Now let's plug in. So I'm gonna have, you can clear this t squared if you want, but no point really. With the other method I'm gonna show you at the very end of this problem, you have to clear the t squared on the y double prime, but you want to leave it there for now. So t squared will equal, now I want to plug this in, so this becomes uh right here I want to go v double prime t squared plus this, and this becomes, of course, plus 2v. Okay. Now I want to do a minus 5t, and this being multiplied by the derivative, the first derivative, so it'll be, and my apologies for the bad handwriting, it's hard to write with a mouse sometimes. So, okay. Now I have this, so what I want to do is I want to distribute this in. So this becomes this, c squared. Okay. So now I want to see, so I'm going to see this will add with this, and this must cancel with the negative 10, because 8 plus 2 is 10, and then 10 minus 10 is 0, so the v's have to go away. Like I said before, they have to go away. So I'm going to be left with this equation, be v double prime t to the fourth plus, and then I want to add these together, so I'm going to get actually a minus v prime t cubed, and this will all actually equal 0. Okay. Now I have that. So now what I want to do is I want to clear this t to the fourth. So this would be v double prime minus v prime divided by t. And this would be equals 0 divided by t to the fourth, which is 0. Cool. Okay, now I want to make a substitution a little bit. I know I can use stuff we learned from the first common if I set this equal to w. So if I say w equals v prime, I can do a separate row of equations. If I can't do it the second order, but if I can set equal w, which is gonna be so v prime will equal w. So I can do. I'll show you how this looks. This will be w prime minus w divided by t equals 0, and this is a w. And now I can say, okay, I can move this over, so this becomes, and I'm going to say w prime will equal dw dt, because I'm taking respect to t, would equal w divided by t. So I'm going to cross multiply these. So this is going to actually switch at these. So I'm going to switch these. So this becomes now, this will also be equivalent to dw divided by w equals dt divided by t. And now I'm going to integrate both sides. This will be integral. I'm going to integrate this. So this becomes ln of w equals ln of t plus a constant, so I'm going to call that k1. Now I'm going to raise everything to the e power because I want to get rid of that ln, and the absolute value does not matter. So this becomes so this becomes w equals e to the ln absolute value of t plus k1. This k1 will come down to make it k2, so, and also this will cancel. E raised to an ln power, we just wipe them both out. They are inverses of each other, so they cancel each other. So this becomes w equals k2. The constant doesn't really matter. You can just call it k or c, whatever you want to call it. This would now equal t. So t. But now, like I said before, um, I made a substitution right here. So this becomes actually v prime, which I'm going to write dv dt, the derivative of v with respect to t, will equal k2 times t. I'm going to move this over, so this now becomes dv equals k2 t dt. I'm going to integrate now both sides. This is separation of variables. That's all I'm doing. V equal, this becomes k2 t squared divided by 2 plus another constant, so I'm going to call this k4. This is going to become k3. Now I'm going to have, so I have v now equals this. So it's going to be k4 t squared plus k3 t squared plus k4. Now what I want to do is I want to plug this. Now I want to find y2. This is not y2. This is v. I set y2 y equals t squared v. So I'm going to plug this back in here. So this becomes y2 equals t squared k3 t squared plus k the fourth. Now I'm going to distribute this in. So this is y2 equals k3 t the fourth plus k the fourth. K4 equals k4 times t squared, but what I have to look at and be very careful about, y1 equals a constant times t squared. There's no constant here, but if I was to set up the general equation, there would be a constant from this, so this just goes away because it says a not constant multiply y2. So now y2 will just be, so this goes away, the constant, you don't need the constant anymore, it becomes y2 equals t to the fourth, and that's your answer. Now now instead of doing closed work, there's actually another method you can do. So I'm gonna show you that right now. If I just get rid of this, feel free to pause the video and write this down. If I'm going too fast, my apologies. I'm trying to go as slow as possible, but I'm also trying to give you the most information in the timely matter. I don't want to spend an hour on one problem that doesn't make sense. But there's a formula you can do which combines all the steps, so you don't have to do all this extra work, but they don't want you to. But it's a very good check. It's an easy check. So I'm going to say y2 of x would equal y1 of x times the integral of e to the negative integral of rho of x. And I'm saying x, it could be t, doesn't matter, divided by y1 of x, all squared, dx. So it's two integrals, not double integrals. So I want to do rho x. So rho x is what I'm saying. You actually have to clear the t. So this becomes y double prime minus 5 divided by t y single prime plus 8y divided by t squared, and this equals 0. Okay. So this is my rho. This is rho of t. This is all be respect to t. I just did x because why not? So now I'm gonna start plugging stuff in. So y of t equals y1 given t squared, the integral of the negative of e of the negative integral, so negative, this is a negative out here, so it becomes positive, the integral of 5t dt, all divided by t to the fourth, because it's b squared, dt. Now I want, so this will become ln, so this over here becomes 5 ln of t. I can now rewrite this as, this goes in here, this goes on top, this will cancel, so this becomes y t squared, and that, if you can see it right now, you can see this is exactly going to work with exactly before. This becomes now t to the fifth, because this will cancel this e, and this be t to the fifth, t to the fourth, dt. This will cancel, this becomes t, the integral of t is going to be y2 t squared times t squared divided by 2, and this now equals t to the fourth divided by 2, and this does not matter, so y2 of t equals t to the fourth. And that's exactly the same thing we got before, and this is a much faster way to do it, but they do want you to show all the work in the way it was showed in class, and not this method, but both work. Next question. Okay, this question. This is a mass spring system, so we know we gotta model this using a differential equation. So the general differential equation would be the mass, U2, plus your gamma which is this is your damping constant, so this would be y prime, plus the spring constant, which is y, and this, since we say there is no damping, so this is 0, and we say there is no force, I believe. Yeah, no force. So, what you want to do is, you want to first find m. So, your first thought is say, oh, m is this. No. M, so, they give you a weight. So if we know from anything in physics 1, we know the weight is a force. This is a force. Pounds is a force. It's like it can be converted to newtons. We don't want that. We want a mass. So how do you find your mass? Well, by Newton's second law, F equals ma, we can say 16 equals ma, and we know a is right here, 32. So 16 divided by 32 is 1/2. So 1/2 equals the mass. And all I'm just doing is plugging this 32, and I'm just solving for mass. And now this unit is actually something called, so the mass equals 1/2, we call it slugs. And this is in the imperial units, so this is what the United States uses. So it would be in kilograms if you use metric, slugs for inches or feet, and it's a little complicated at first, but then you just kind of get a handle of it. And also you gotta notice feet per second squared, and you have a downward velocity of feet per second, but I'm given inches. So what I want to find is, so I know my length of the string would be 8 inches, but I want to say, okay, first my length is inches, but everything else is in feet, so I want to convert that, and we know 1 foot equals 12 inches, so I can say length would equal 8 divided by 12, which is going to simplify down to, this can be factored, so it'd be 2, and 3 I'm going to divide 4, so it'd be 2/3 feet. All I want to do is convert to units I can work with. I cannot just make up units as I go. I cannot just use a force, a mass. It will not work. It would give you some crazy ass numbers, and it's not going to work. Also, I want for my initial conditions. So how do I figure out my initial conditions? So I have my length right here. Okay. And it says at initial time t should tell me when u is 0, contracting. So the mass just push upwards. So if I have a spring like this, and I'm pushing it upwards, and we're going to take always the positive will always be down. So I'm pushing it up, so we know the initial position must be negative because I'm pushing it up. So I'm going up, and it tells me it's contracted the spring by a length of 6 inches. Okay, so it becomes negative 6 inches, but I gotta make sure it's in feet. So 1 foot is 12 inches, so 6 divided by 12 is 1/2, but it has to be negative 1/2. Cool. Okay. And then y prime, it tells me it's a downward velocity of 2 feet per second. This is in feet. So downwards, like I said before, we take positive, so it'd just be regular 2 feet per second. Okay, cool. So I pretty much have everything to start besides my spring constant, which is very easy to find. So of course, spring constant will equal the force divided by the distance. So Fx. or Fy, whatever you want to use, or D, whatever, it does not matter. So this becomes force. This is not my force now, this is my mass. This is my force. 16 divided by my distance. It's good. So my length of the string, which is L, or X. So this is what my L is right here. It'd be 2 divided by 3. I want to simplify first, so this goes away. This 2 goes in 16 8 times. 8 times 3 is going to be 24. Okay, cool. So I got 24. Now, what I want to do is, now I have everything. I just plug in now everything. Gamma's 0, so I can say gamma equals 0. This goes away. I have my mass, so 1 half u double prime plus 24 u equals 0. That's your answer. It's a very easy problem, easy 12 points, doesn't ask you to solve. But I can make this a little easy. I can multiply everything by 2, I'll get 58, and I'll have this cleared, but it doesn't really matter. It just wants you to solve. It does not want you to solve. Like it says right, do not solve. Always read the questions. Always read them, because it could be just, if you don't want to solve this is going to get pretty messy. I'm assuming, because it's not going to be nice numbers. He just wants you to see pretty much the unit conversion and all that stuff. So that's how you do it. So next question will be number 4. Um, 4. Okay, this is an actual real mass spring system right here, and this is, well, this is actually one he wants you to solve, and it has 4 parts, and it's very easy. You just got relax and think about it. Okay, it's just because it says mass spring system doesn't mean it's gonna be something different than what you are doing. It's just the regular homogeneous and hetero and non-homogeneous equations. You know, with the T, it's basically the same thing, just has a little more applications to it. It's a model of the real world. So the first part says gamma equals 0 and the force. So if I have a force on it, it makes it non-homogeneous. Since it says force is 0, I can say this is a homogeneous equation. So what I'm going to do is I'm going to say, I need my brush. So this is part A. This would be 3r squared. This is 0, so this just goes away. Gone. Plus 75. There's no r, so this just equals 0. So first thing I want to do, I want to divide by 3, so r squared plus 25 equals 0. I move this over, and this becomes negative 25. So r has to equal plus or minus 5i. Okay, so that's pretty straightforward. So now I'm just going to use the equation I used in the very beginning, the first questions. Y equals C1 cosine of 5t plus C2 sine of 5t. Just like I did in the beginning. You know, it all comes full circle. Full circle. It's not anything new. They're not pulling any problems from their ass. It's very straightforward, you know. Now I'm given the initial condition, so y of 0 equals 3. So what's cosine of 0? Well, that's going to be 1, so I plug in 0. It doesn't matter what multiplied by. It's going to be C1 would equal times 1, so it's going to be C1. And the sine of 0 is 0, so I got plus 0. So very easy. C1 equals 3. Okay, that's very nice, you know. Like, it's right there. The answer's right there. You don't, it's not a hard question, but you might panic when you see, oh god, a spring, this is going to be really hard, but it's really not, you know. Just look at it, read the problem, do what you know, and then it's very simple. Now, the same thing before. Now, I just got to take I just got to do one extra step, and I take a derivative. So, y prime would equal negative 5 c1 sine of 5t plus 5 c2 cosine 5t. Okay, well, evaluate this at 0 and negative 15, so this becomes negative 15. I'm going to plug in 0 for each, so I know this constant's 3, but I really don't need it because this all goes to 0, so this goes away. And of course, cosine of 0 is now going to be 1, so it's going to be, this will equal 5c2. We know what negative 15 divided by 5 is, so c2 just equals negative 3. And that's all they want, so my answer will be y equals 3 cosine of 5t minus 3 sine of 5t. And if you got this part wrong, then I'm sorry to say, but you definitely got B wrong, and you probably got, I mean, you maybe got C right, but you could have got D right, but if you got this part wrong, you definitely got B wrong. So how do you do B? Amplitude phase form. So this is going to be kind of the general form, be y equals r cosine of omega t minus delta, which is your phase shift. So that's all I'm doing. So what is R? So you could make an argument that says basically R is the Pythagorean theorem of this whole thing because you have cosine and sine. And there's actually an equation. I'm not going to show it here, but there's an equation. You can say that will 100% always get you R, which is just going to be Pythagorean theorem. But there's actually a proof for that, but I'm not going to go in that in this video. I'm just going to show you how to get R. So R equals, so I'm going to say this is always A, this is always B. That's why we write it in this form. That's why it's cosine first and then sine. It's never BA. It always has to be AB. And then that will screw up actually the delta. If you have these reversed, you will get the question 100% wrong all the time because you will reverse sine and cosine. Or, yeah, cosine or sine and cosine. You'll screw that up, and that will get you not the right phase shift. So how to figure out R, this is Pythagorean theorem like I said before, so it's going to be 3 squared plus negative 3 squared, which is always going to be positive, so no need to put negative in there. So that means this would equal 9, that'd be 18, so square root of 18. I can make this a little bit smaller. I can make this a little cleaner. We can say, okay, 9 goes in 18 twice, that means 9, so this could be written as 9 times the square root of 2. This becomes 3 times the square root of 2. That's my R, so that's one part done. And now what is omega? Well, omega stays the same. So omega would equal 5. So I got 2 parts done. I'm almost done. So how do you do delta? So delta, okay, delta can be a little tricky. What I do for delta is, I'm going to say delta equals the arctan of B over A. Okay, cool. Now, what is B and A? Well, B and A is this. So it's actually these values right here. This is B, this is A. So I'm going to say delta equals arctan of 3. I'm not going to put a negative there. You're going to see why. So arctan of 1. What's arctan of 1? That's 45 degrees also. So I'm going to call this arctan naught. So, I mean, delta naught. So delta naught would equal 1. This is not my, not 1. My bad. This is pi over 4. Or 45 degrees. We're going to keep in radians because delta is always in radians. And, these are radians too. So if you had delta in degrees, it'll screw everything up. So make sure you're always in radians. So why is this not, the answer? Well, I'll tell you why. So I'm going to draw a little graph right here. So I'm going to say, so this is this is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. So this is positive x, positive y. We can say x is cosine and then y is sine. I have a negative sign. That means my function must be going like something like this. That means it's going in the negative y, positive x. This is I'm going to call this positive x. This is positive y. And of course this will be negative and negative. So we can see that right now. I have a positive x, negative y. So that means I have an angle going like this, or I can have a negative angle going like something like this. I can say, okay, so it means my actual delta, so my delta does not equal pi over 4. That's my that's my reference angle. That's just my base angle. That's just in the first quadrant. And once my actual delta would be negative pi over 4, or it can be written as 7 pi over 4. They're both equivalent because that means I'm going this way, one I'm going this way. It does not matter. So now I'm done. I'm done now. So y equals, this becomes 3 times radical 2 cosine of omega, which we know I said before, it was 5t. It's always the same. If these are not the same, you definitely screwed up somewhere, so I would definitely check your work there, because these have to be the same, or it will not work properly. And now minus a minus, if you put a minus here, you're going to get it wrong. If you put a plus here and use this value, it's going to be wrong. So a minus, so it becomes a plus pi over 4. And that's your answer. That's all they want. It's very straightforward. You just have to read the question and just do it. Okay. Now this question is, next question is, I'll say, it's tricky at first, but it's very easy. Just like this question. It seems tricky, but it's actually very easy. What I want to do. Okay, I found my homogeneous equation right here. I'm not going to have the 3's there. I'm going to put y homogeneous equals cosine of 5t minus c1, that should be plus c2 sine of 5t. Okay, that's my homogeneous equation. That's like step 1. Now I have a force acting on, so what the hell is going to be my particular solution? Okay, so y particular would equal, well, we know the guess would be a cosine of 5t plus b sine of 5t. So what the hell does this mean, Renaissance? That means the omega, so actually I just gave it away. I jumped ahead of myself, my apologies. This is the correct answer, but I'm gonna explain why. So this is omega. So how do you have, so if it's, if and it must, so th so this, it has to follow this. So if in this, it has to be omega naught, which is gonna be, this is gonna be omega naught, so these are omega naughts, divided by the real omega, like the new omega, has to equal 1. Okay. How did I do that? Okay, well, I know what omega naught is. That's 5. Divided by omega equals 1. I'm going to move this over, so 5 must equal omega. Okay, so omega just equals 5. So omega must equal 5. And it's greater than 0, which you know. And that's all I gotta do. That's part C, so that's a free 5 points again, you know. It's, if you didn't know what you were doing, you wouldn't have gotten the question, but it's a very, what I've seen from these exams, it's like if you don't study, you don't do the work, you're not going to get the questions. But if you put some time in, you're going to eventually see, okay, these questions are very similar to every year. You know, these are fair exams. They're, if you don't study, you're going to fail. If you study, you should do fine. But next question. So this is critically damped. So what does critically damped mean? So I'm going to say delta. I'm going to find the delta in a little bit. So delta has to be greater than 0. And delta must equal gamma squared minus 4 mk. So you actually, what if you fucked up? Actually, they gave it to you, so you would have got that right if you didn't make the equation. But whatever. So this is gamma, by the way, not y. So I have m, and I have k. All I do is plug in, and this would equals 0. So my mass is 3, and this will be 7 equals 0. Okay, now I want to move this all to one side. I'm solving for gamma, right? So this gamma squared would equal 3 times 75. Okay, now what I want to do this, I just want to multiply through. So this would get me 75. That's 4 times 3 is 12. Okay, now do this. I'm not going to do this in my head. This becomes 10, 14, 5. This becomes 7. Add this up, 0. This becomes 0. 1, 2, 7 is 9, so it becomes 900. So I got gamma squared equals 900. Now I want to do gamma would equal plus or minus 900 squared. I can separate this. If you know 9 times 100 is 900, then you can do this question. You can simplify this. It's not very hard. You just got to do this plus or minus 9 times, well, the square root of 9 times the square root of 100. But if you just look at it, it's like, well, it gets me 900. 9 times 100. It's not too bad. And now this simplifies down to plus or minus 3 times 10, which is going to be gamma would equal plus or minus 30. Now, like I said before, for critically damped, has to be greater than 0. If it's less than 0, just damped. If it's 0, it's just, it's not critically damped if it's equal 0. So, well, I don't have 0 here, so it can't be the second option. Yeah, I can pick between positive or negative. Well, like I said before, critically damp, if they say critically damp, it has to be greater than 0. Damp just means if it's negative, it's just damped. They would say when this is damped. So, and they usually don't give you when it's damped. They just want to find critically damped. So, gamma must equal 30. That's your answer. And that's it for this question. You know, not a very hard question. It just takes a little bit of thought. And we can move on to the next question. Alright. So, this question. So they give you a homogeneous equation. They say, so find the associate homogeneous equations and demonstrate they are fundamental solution sets. Okay. So first thing we gotta do, like we did for 4 questions, I forget now, we change this to r. So r squared plus 4r plus 3 equals 0. Okay, so what multiplies their 3 as their 4? That's gonna be 3 times 1. So this becomes 3r plus 3. Okay, cool. So what I want to do here, well, all I want to do is I want to factor out r and then factor out 1, so r plus 3, and this becomes plus 1, r plus 3. All I'm just doing is factor this equals 0. So I can factor this, so it becomes r plus 1 times r plus 3. You can do a quadratic equation. It works both ways, does not matter. So that means r would equal minus 1 and minus 3. Okay, easy. Easy enough. So how do I want to solve this? Well, all I want to do is just say, so I got my two solutions, so y would equal c1 negative t plus c2. Okay, I have that. But if I just leave this, I didn't prove that they are fundamental solution sets. I have to prove it. Now how the hell do you prove it? Well, it's very simple. You just do the Wronskian or determinant of, so the Wronskian states it's a 2 by 2 matrix of y1, so I could call this y1 and y2, so y1, y2, and I'll take the derivative of that, so this becomes negative e to negative t, okay, and then it doesn't matter which order, it could be y1, y2, and this becomes e to negative 3t times, well, I take the derivative of this, so it becomes negative 3 e to the negative 3t. I close my matrix. Now I'm going to do the determinant. Same thing as cross product, which we did in physics 2. I'm going to multiply this and then multiply this, but I'm going to subtract. First, when I multiply this, then I'm going to subtract the multiple of this. Let me demonstrate. So this one, and this cannot equal 0 if it's a fundamental solution. It will always not equal 0 if you get something that equals 0. You screwed up somewhere, so it does not equal, it always will not equal 0. So first, this becomes negative 4. Not negative 4. That is the, not negative 4, that. So it becomes negative 3 e to the negative 4t. And this becomes a minus time, minus minus become plus. This becomes, this will become, yeah, okay. And this will equal, not equal 0. This be now simplify down to this. And if you did it the other way, you can get positive or negative 2. Since I got a negative 2, it does not matter. So I actually was stopping for, I was like, I thought this had to be positive 2. It doesn't matter because we know e to the negative 4t can never equal 0. So this checks out. This cannot equal 0. So I got my fundamental solution. I just proved it right there. And that's it. So these are my solution sets right here. So I select this. Make sure. Yeah, it's negative 3. Yeah, interesting. So I'm going to get rid of this Wronskian, whatever you want to call it. Does not matter. So you got to know what you're doing with that. So next question. Now they give you now a non-homogeneous equation. So this is going to be, so I already have my first guess. So it becomes this. So I have my y homogeneous. I'm going to call this y homogeneous. I'm going to write this over here. So it becomes c1 e to the negative t plus c2 e to the negative 3t. Now this can get a little, these problems can get pretty messy. They are pretty long. They take a little bit of work. So let's have some fun with this. So it becomes y particular. So I'm going to take a guess. So we know I've got a t, if I got a t here, that means I got always do one less power. So if I got t squared, I'll have 3 constants. So say I had t squared, my y particular would become a t squared plus b t plus c. And it'll be multiplied by whatever I have there. So I don't have that though, I have just t. So I'm going to do at plus b. And now, god damn it. Now you're going to say, oh wait, I thought exponentials have a constant on them. Well, they do. And I can put a constant there, so I can call this c, e to the t. But for constants math, if I multiply constant by constant, it's just another constant. So I don't need a constant here at all. Not one bit. I don't need a constant. It's a waste of time. I'll get a times c t plus bc all times e to the t. Like everything become. So it's like it's pointless to do that. Just do this. Like they're not different. It'll just be a. It will convert back to a t and then b. So it does not matter. So, and I also check, make sure that these are not the same. This is homogeneous. If I have a same. If this was negative in here, then that means I have to multiply everything by t. But I don't. It's just t and negative t. So they're okay. They're not the same solution. So I want to take two derivatives of this, so I'm actually going to distribute this in. So this would equal, so derivative of t would be a e to the t, derivative of e to the t, it would just be plus a t e to the t, and the derivative of b times e to the t is just b e to the t. And I'm not going to show you me proving this derivative same, that's Calc 1 stuff, but just something people should know now in differential equations. Okay, cool. So you want to combine like terms, like if I have an e there, it's going to make my life a lot easier than having a million derivatives out here and keep going, especially when if these get complicated. It just, it makes it a lot harder. So I want to combine like terms. Makes it a little easier. And then when I plug back the two derivatives in this equation, the top of this equation right here, makes it a little bit easier. I'll show you that. So I'll take my second derivative, so this is this. So second derivative of e to t is just going to be, well, constants. The constants stay. Derivative of e to t is e to t. Now I got a product with her. This becomes a e to t plus a t e to t. I won't bring this in now, so d2 equal 2a plus b e to t plus at e to t. Okay, cool. I got room. So now what I want to do, I want to plug them back in this equation, which will become, so we'll have a t e to the t plus 2a plus b e to the t. That's my second derivative, so now I'm gonna add this to plus 4 times my first derivative, which is this. This is like this. Plus. Now, my y particular would be this. So, and I gotta look back. So, plus 3 times my y particular, which is gonna be a t e to the t plus b e to the t. And now I'm saying this equal to this expression right here, because now I have this derivative, this differential equation, and I have this g of t, so this would be now equal to my g of t, which is going to be negative 2 e to the t. I'm just trimming the e to the t in, plus a t e to the t, and this is t. Now, what I want to do, well, if we remember from partial fractions, in Calc 2, if you took Calc 2 here, we had to do we could pull out, we can set, so if I had like x squared on one side, I had a bunch of x, like ax squared plus bx squared plus all whatever else you had, you can compare, you can say x squared will equal a square ax squared plus bx squared, and the a squares cancel. Same type of method here, but it's a little different. I have now e's, so if I have e and a t times e to the t, so I have this here and an e there. Now I want to set the ETs equal to the ETs and the TETs to the TTs. That might sound a little confusing, and I'll show you what I'm talking about, because it's hard to say, and it's like, what the hell are you talking about? Well, I'll show you. So I'm going to do the ETs first. So this would equal, so negative 2, the ETs will drop. Actually, I'll do this to show you what happens. I got ET here, I got an ET here, I got an ET here. So you got 3 ETs. So if I look, there's nothing surrounding this. There's not surrounding anything. So just besides this, so this becomes 2a plus b. Okay. Now I got ET here, but when I pull it out, it's something with, like, I call it like it's like a guard in a way. So I pull this out, but I got stop here first, which multiply everything by a factor of 4. So this becomes plus 4a plus 4b. Instead of distributing this all back in, you can do it this way, and in my opinion, this way is a lot easier than doing it sometimes distributing everything in. It just makes it messy. I like to keep it like this. It's like, okay, if you just realize you gotta pull it out and multiply it, you are golden, because this method is very easy. And then plus 3b, because I pull this b out, I get stopped by this 3, and it means I'll multiply by a factor 3. And now this will be all multiplied by a factor of e to the, this. So, okay, cool. E to t will cancel. Okay, now I'm left with this, so I'm left with 6a, And now this becomes 4b plus 4b, so it becomes plus 4b. Not 4b, Nick. It's 8b. 4 plus 4 is 8. Equals negative 2. Now, can I do anything with that? Not really. Doesn't help me much. I can simplify this a little bit. I can say 3a plus 4b equals negative 1. And all I just did was divide by 2. I didn't divide by negative 2, I just divide by 2. This is one equation. So, did it help me? Not really. I'll try the t's. So I got one t out here, I got another t right here, I got another t right here. And this is my t, so I can say 8te will be equal to a. I got t right here and a, but when I pull it, I get stopped by the 4, so it'd be plus 4. A. And then I got the 3 right, I got 3 and I got a right here, so when I pull up the a, it's going to be stopped by the 3, so it'd be plus 3a. So when you do these problems, you see some type of symmetry a little bit. You kind of will see, oh wait, I have 8b here, I got an 8a over here. You see some symmetry between the opposite variables. It's a little bit of insurance to say, okay, maybe I'm doing this right, and this will be all multiplied by t this, so this just cancels out. Okay, well that's easy. And now I'm going to get 8a equals 8. Well, that was easy, so a equals 1. Alright. Well, now I'm done, basically. So, all I need to do is plug in I have a equals 1. This is a second system equation, but it's not very complicated. Why not just pull in here, so it'd be 3. 3 times 1 is 3, plus 4b equals negative 1. I move this over, so 4b equals negative 4. These cancel, so b equals negative 1. Am I done? No. Now I can say, okay, my y particular will equal, I guessed it right here, so it would be t, and also wants me to solve these equations, so it would be t e to the t minus the particular was right here, so minus et. Okay, so now I want to solve the initial conditions, so I am almost out of room, so this is my y particular. So I need my homogeneous, so my homogeneous equation is right here, so this becomes, so y would equal c1 e to the negative t plus c2 e to the negative 4t, I believe. Let me check that. 4t or 3t? 3t, my bad. And now I have my y particular, so by theorem superposition, I can add y particular and the y homogeneous again to get my actual y. And all I'm just doing, like I said, just add them, basically. It's not. It seems like principal superposition sounds really complicated. All I'm just doing is adding two things together, basically, which is this. Okay. Wow. That was not too bad. So, all you want to do is plug in 0, so what I say, 0 equals 0, so 0 would equal, this becomes c1 plus c2, and now this goes to 0, and then this becomes negative 1. Means c1 plus c2 must equal 1. Okay, now I want to take a derivative. So this would be y prime would equal negative c1. So I don't really have anything that can help me right now, so this, and this becomes minus 3c2 a to the negative 3t. And now this becomes, so I take the derivative of this again, so it becomes e to the t, and now this becomes t to the t. And then of course the derivative of this would be the minus e to the t would be minus e to the t. These cancel, and I'll plug in again 0, so when I plug in 0 again, so 0 equals negative c minus 3c, and then 0 here goes away, so this would be 0, so now I'm going to say, okay, c1, negative c1 would equal 3c2, and now I can say c1 equals negative 3c2, so now all I want to do is plug in c1, b is negative 3, c2 plus c2 equals 1. That means c2 equals a negative 1/2. That means to have this equation, that means c1 must equal, I add this to 1, so it becomes 3 over 2. That means my final equation will becomes y 3 over 2 e to this plus negative 1/2 e to the 3t plus t e to the t minus e to the t. Okay, that's my final answer. That was a lot of work for this type of problem, but it's definitely worth a lot. It's worth a lot of points, so definitely don't skip these questions or you want to lose a lot of points. But it's not too bad. They don't make them terrible. Like, this is a very fair equation. It could be also sine here, which we showed before for the spring mass system. So it's on the last question, which is the last question of this exam. Only 6 questions, not too bad. Um, so, but look right here. I can't guess any solution here, and they give me 2 equations. Okay, they give me 2 y1 and y2. So, look at this one. I can't guess any solution here because this looks like some crazy function that I'd have no idea to do. So, um, I don't know. So, what do you want to do? So, we can't take a y particular right away. We can't guess a solution. So what you gotta do is, the first step you will do is do something called, which before is the Wronskian. So the Wronskian is called the 2 by 2 matrix. I'm given y2 and y1, so it's pretty straightforward. You see this, you take the derivative of this, so it becomes negative 2, 2, and this becomes, now this is a product rule, so it becomes this minus, and that's my 2 derivatives right there. Not terrible, so I'll plug this in, so like this, and I'm gonna take I take the derivative of y1, so this becomes, and this becomes, okay. Now, like I said before, you do the determinant, so it becomes the Wronskian will equal e to the negative 2t. Okay, and it'll be a minus, so it becomes plus. I'm gonna subtract this from this cross. I'm gonna do something like this, and I'm gonna do a minus this, but a minus a plus, so it'll be plus 2t to the negative 4t. Okay. So what I want to do here, so I'm going to distribute this in, and this cannot equal 0. So when I distribute this in, I'm going to see one thing that's going to be a common occurrence. This will become e to the negative 4t minus e to negative 2t e to the negative 4t plus 2t e to the negative 4t. And these just go away, and this will not equal 0, so we know e to the negative 4t can never equal 0 due to by the graph, and also just knowing exponential functions, well, the e function just never touches 0 ever. So that's it. So that's it for this part. So so now we'll figure out my u1 and v2. So to figure out I can't guess a particular solution. I gotta figure something out. So my y particular would equal y1 times v1 plus y2 times v2. Now how the hell did I figure out v1, v2? Well, I'll show you. v1 would equal the negative integral of y2 times g of x. G of x is this function, so this equals g of x. So e to the negative 2t divided by the t squared plus 1 is g of x, all divided by the Wronskian of y1, y2, and this will be respect to xt, actually gt, dt, and that's my v1. So my v1 now equal the negative integral of where is y2. Y2 is right here. It becomes t e to the negative 2t times this, so this becomes e to the negative 2t divided by t squared plus 1, and now this will all be divided by my Wronskian, so it becomes negative, so this becomes dt, and this integral must be bigger. So first thing you can see is this well, so this will multiply with this. This now becomes e to the negative 4t divided by e to the negative 4t. So these just cancel out. And now I'm left with this. So this is technically going to be written as this. Now how did I get this? If you're confused is, well, this becomes t over t squared plus 1 divided by 1. So of course anything divided by 1 is itself. So that just goes away. So this becomes this. So looking at this is, it's like, okay, what do I need to do? Well, simply just gotta say it's its u sub. So I can see this becomes, this is u t squared plus 1 du would equal 2t dt. This moves over, so this becomes divided by 2. So this my v would equal. So this becomes 1 over negative 1 over u du, which now becomes negative ln, and there's a 1/2 out here, so multiply by 1/2. Absolute value of t squared plus 1, all divided by 2. Now I can get rid of these absolute values because the t squared plus 1 will always be positive. Doesn't really matter though, but just for convention's sake, this t squared plus 1 will always be positive. So my v1 actually equals negative ln of t squared plus 1 divided by 2. You don't need to, but it's always good to just have proper notation. Opposite values are not needed. So now I want to do, of course, v2, which is the same, basically same thing, just a little different. So v2 will now equal just the plain integral, no negative integral, of y1 g of t divided by the Röntgen. So I'm going to put that as w. I'm not going to put y1 and y2, you don't need that. Well, you kind of do, but it doesn't really matter for this. So v2 equals, so y1, I'm given y1, which is out here, so it becomes the integral of negative this. So negative 2 t time, of course, the same thing before, so this becomes this. I'll write this a little neater, so this becomes something like this, and this will be multiplied by. Okay, now I have this. Same process is going to happen. These exponents will technically subtract well, add together, but negatively, so this becomes the same thing, so these just cancel out. And I'm left with now the integral of 1 over t squared plus 1 dt. Well, we know this from Calc 1, this would be arctan of t, so this becomes arctan of t, and do not worry about constants, they do not matter, so right now. So, am I done? No, I gotta find my y particular. So my y particular would equal, I have to say y1 times v1, so y1, so what, my y1's down here, well my v1's down here, my y1's up here, so y1 becomes negative 2t times the negative natural log of t squared plus 1 all divided by 2. That's my y, that's part of my y particular. That is the first part. Now it'll be plus y2 t e to the negative 2 times arctan of t. Okay. Am I done yet? No, I'm not. I have one more last step. You know, it's kind of like building blocks. I have to put this with something else. It's just like kind of like, it's half a house. To build a full house, I need something else, so I just need my homogeneous equation. My homogeneous equation is the other half of the house. So I put them together by superposition theorem or principle. So I just add these together. So my y homogeneous is these two. This is they're y1 and y2, so it becomes c1 e to the negative 2t plus c2 t, and now this is my homogeneous. I want to say plus this, so negative up here, plus a negative e to the negative t ln of t plus 1, this is squared, all divided by 2, this will be plus t and that is your answer, and that is the final problem for this exam. I hope you enjoyed this video. I hope it was informative. Hope I did a good job explaining things. If you have any questions, you can leave them down in the comments below. And I wish you success on the second common. Thank you.